Hello, welcome to Apidays Paris. My name is Stéve Sfartz. I work at Cisco. Today we're going to discuss why API contracts matter. Along my career at Cisco, I've just put more and more energy looking at API contracts. So I will be happy to explain what is it we're doing with API contracts, what it is at Cisco. I'm a principal architect. I lead the API experience program. This is where we define internal standards for APIs regarding design, the API lifecycle and documentation for APIs. And what is our end goal and target is to provide the best possible developer experience for our customers and partners. So that's what drives my days. It's been a few years. So what's an API contract? Or for sure, an API is already a contract by itself. It's a technical contract, of course. It's not a business contract. You send a request, you get an answer. The API consumer is code application, and the API provider is a vendor, a product, a service, whether it's on-prem or cloud-based. In order to formalize these contracts, we have a beautiful language for REST APIs. It's called OAS for Open API Specifications. It's very easy to read through, so that's great. And what's now the definition of an exact definition of an API contract? At Cisco, we've defined it as the document you create based on the Open API specifications. The whole sometimes an API is large, so it won't fit in only one document. So you may need several documents. Altogether, these Open API documents define your API. We call it the API definition. Of course, if you use the Open API specification, the API definition is composed of Open API documents. But imagine you do all the types of style, another style of API, then in this case, you may need a different specification, whether it's async, GraphQL, protobuf. Okay, so you have all these sets of documents that define your API. And on top, the contract is not only the definition of your API, as we see it, it's also the life cycle of these documents. And the life cycle means how is it going to evolve? How are they going to evolve? These Open API documents with revisions, with major version, minor versions. And along the life cycle of your API, we will generate API change logs automatically from these Open API documents. Of course, when you generate these API change logs, you want to avoid introducing breaking changes across minor versions. And you also need to have a solid deprecation policy whenever you change to the next major version. So altogether, this defines the concept of API contracts. This talk is about the contract matter aspect and how do you organize as an organization in order to track the quality of an API contract. So this is the scale and the scoring system we've defined for Cisco. And it starts from very low, you're a non-reliable API, that's bad. Your contract keeps changing. There is no change log. That's definitely something you have for internal APIs that are product-led, UI-led, sorry. So think about the user interface. You want to, that's not a public API. You just need an API to create a website, a mobile app. So that's your internal API. You're not supposed to publish it. A very common pattern is to start from this API and to push it publicly externally. That's not the best way of doing it because you will often introduce breaking change. You don't really manage your life cycle. So that's not what you want. So that's what we qualify as unreliable. Above that comes an evolving API contract. That's typically you've got a product. Inside that product, this product has its own versioning, so V1, V2, V12, etc. Maybe it's a code name. And along that product, you also have an API that comes with it. And in this strategy, you would really care about your product, but not that much about the API. So the API is not really versioned independently. It gets updated every time there is a new release of the product. That leads to a lot of inconsistencies, breaking changes. Generally, the definition, the Open API document you produce are not complete. You don't really care that much about their completeness, and the changelog also is not is most generally not generated or very partial. What we really want is a versioned API contract. So in a version API contract, you've got a proper API versioning slash v1 slash v2 slash v3, your definition. So all your Open API documents are complete, and you've got a complete change log. So your consumers are already ready to consume your API. So this is green. Very green goes one way upper. So we will discuss a bit later about what very green is about. And overall, this strategy defines the quality of an API contract. So let's look into the details now about how can you organize uh, for to measure your API contract quality. So first thing, an API contract, it's going to be a journey for many teams. So maybe they start from evolving, they move to versioned, or they start from unreliable going to versioned. The minimal stage, you want to be it's versioned, of course, as you already understood. And what you will want to capture is you will want to discuss, engage with every team in your organization, and then define a timeline by when they will be in capacity to move from their current state to a versioned API. This timeline to execute, and that will define their end state. And that's really great to start communicating across an organization because you set expectations clear about you acknowledge where your API is standing today. The contract is still fragile, evolving or unreliable. And in the next 12, 6 months, maybe 18 months, you will deliver a better API contract. Generally coming with a new major version of your API, of course, if it was really, um, um, if you had set very low expectations before. So going from unreliable or unreliable to versioned will certainly need a major version of your API. So in terms of tracking these efforts, this is an example of how we've organized at Cisco, looking at the design process, definition of the API, the changelog, the versioning strategy, the lifecycle itself, deprecation, and backward compatibility. And for every API that is on the portfolio, we look at we do an assessment, and while after having done this assessment, we organize with the engineering groups and capture their target within the next 6, 12, or 18 months. What goes after 18 months, honestly, we don't really care. We consider that's too long term. We really care about the next 6, 12, or 18 months. So doing this work, as you understand already, it's a lot of manual work. So it's okay if you've got one API or two maybe, and not too many and frequent releases, but very soon you have really realized maybe if you're in this business, or you will realize that you will need some automation. And the automation comes from doing static analysis based on Open API documents. Luckily, we have the Stoplight team who created a beautiful tool called Spectral. It's an open source linter that can take your Open API documents, run some rules against them, and give you an output that with severity levels for every rule, from warning, error, hint. You can customize, of course, for every rule which severity level you're interested in. And you can also create extra rules. So think about all the work of checking the design when I was showing these different dimensions here, these categories: design, the definition, the versioning, is it backward compatible? Instead of just doing these checks manually, you can use a tool like Spectral, such as Spectral, in order to automate this work and make it more reliable, consistent across your teams. At the end of the day, for API contracts, I will give you now the example of the one we created at Cisco for contract completeness. So what does it mean to have a contract technical contract of an API that is complete. It means you have defined every structure that your API can return. And I'm doing a list here. Of course, the Open API document should be well-formed. You have meta information provided, one version only in your API. We've been seeing some Open API documents which have a mixed, may have a mix of V1, V2 operations in their path, which creates some confusion, of course, for your consumers. Which API version am I already using? So this is typically not an API-led versioning strategy. You must have open operation identifiers. This is definitely important, an operation identifier, if you want to generate code and also uniquely identify your operations over time. So it should be there and it should be unique. That's the first stage. Success status code, of course, but also error status code. If there's no error, there's always an error. There's always something showing up. So good chance that if your Open API does not contain any error, that means that it's not complete. The errors have just not been documented, and this is what you will want to flag. And for every response, you want a schema also. So altogether, these different rules, and we can call them requirements. These different requirements I just mentioned, this translate to spectral rules. So here are examples of names and what they do. Success code, what it means. You certainly in your own organization define a range for these codes, 200, 201, 204. And then you can also look at the single versions I was explaining, operation ID required unique. So you come up with a list of rules that behave and organize as you have defined. And when you define what means the API, the contract completeness, the completeness of contracts for your API. And then along your life cycle, along the API lifecycle, you will have your engineering teams and also documentation teams working around revisions of Open API documents. And so it starts early with certainly program, product owners, managers, creating a first high-level design, engineering teams looking into the details of the completing the schema, so they create really the completeness of the contract. Documentation teams, they add descriptions and examples, which are very important for the published documentation, but they do not matter. They do not matter that much for the contract itself in terms of completeness of the contract, as we just saw. And then you publish, once this document is getting rock solid, you publish it with a CI/CD toolchain, if possible, so that you can automate the work again. And you track versions and revisions of these Open API documents, typically using semantic versioning, because it helps get clarity on what is a timeline, what is the life cycle of this API. Okay, so you've got a solid contract. You've created linting rules using Spectral or another open source tool or a vendor. Luckily, you're at API Days this week, so you will see many vendors in the partner space. Now, you've done your best effort. You've looked at the completeness of your contract, but what's really happening is suddenly a new operation or update to an existing API. They did not get properly annotated, which means the Open API document, the latest revision, does not reflect this change. So what do you have now? You're in a situation when where you have drift between your API contract and the actual API deployment. So this release is not really exactly the same as the contract. So this has several implications. The first one is, this operation, good chances it didn't get tested. fuzzy testing, whatever strategy you use, generally nowadays you want to leverage these Open API documents you have. Your documentation, when published, will be incomplete. So this particular operation that got added or updated will not be reflected in the latest version of your documentation. And eventually you introduce some security vulnerability, maybe some personal information of users didn't get screened, sanitized by the different tools you use internally for compliance. So what is it you can do? First, let me show some examples. So this is an undocumented operation. So this is on the left is what you have inside the existing Open API document that you think is the source of truth. And on the right is what shows up at runtime. So that's, of course, this path did not get documented. And that's a get on slash tags. You could have simply just one query parameter that is not documented. So that's what is frequently happening if you missed an operation and an update while doing some maintenance or an incremental update to your API. Or zombie would be something you think was deprecated and you marked as deprecated, but at runtime we still see some traffic coming in. So that's definitely situations you don't want to be facing. So what is it you can do? We strongly encourage teams to look into working on their CI/CD architecture. Whenever there is a commit in the code, and I'm sorry for this slide, I'm going to fix it live for some reason. It does not show, so this is what you should see right now. So someone commits some code, there you've got along your CI/CD pipeline, you have organized with different CLIs, command line interfaces, or code from your CI/CD integrations and extensions that directly interface with your own Open API static analysis that you have built inside your organization. And you can also add, of course, extra API scoring systems and solutions. Again, at Apidays Paris this week, there are many solutions that go into security, vulnerabilities, WASP.10, and other types of scoring systems. Then you deploy to production. If you're on a Kubernetes cluster, you will have some sort of a gateway or proxy that takes you to these documents. Up. And along the work of this controller will be filtering out every piece of traffic information, and that's how the actual traffic will be compared to the different Open API documents and to the latest version of the Open API document that was published for this deployment. So this is a typical CI/CD workflow. At Cisco, we've got the solution called Panoptica, the solution to application security for cloud applications. So if you're nearby, please pass by the booth. We can discuss about, of course, API contracts, different practices we have at Cisco, and we will also be very pleased to show you a demonstration of Panoptica. The URL to find Panoptica is panoptica.app, and there's also some trials and demos available on the site. So let me continue with the presentation. We've seen and we've discussed more, and now we've got the details with the arrows I needed. Thank you so much. So let's sum it up. What is it we're getting here? We went from, we saw the different categories of health for contracts, from unreliable to versioned. And what we qualify as a highly reliable contract at Cisco is an API that has definitely an API-led versioning lifecycle, /v1, /v2, /v3. The deprecation policy is published, well organized, clear timelines before sunsetting an operation. So such example would be as a 12-month minimum before deprecating an operation, all the way up to 18 months. recommended minimum. Automated change logs. That's important. You don't want to generate change logs manually. Um, you don't want because your API will get larger. It will take some time. It will be human, not. It will be just you will be facing some errors. Even the output of that change log will be inconsistent across revisions of your API. So you want an automated change log. Um, for that, you certainly want to have a complete definition, because imagine your Open API document is complete, and I explain what completeness means. In this case, you will be in capacity to fully generate the change log by creating a diff and looking at the difference, comparing the latest revision with the previous revision. And generally, you want to do that incrementally and also across major versions. So whether you are on revisions of your API or major versions, that will help you generate automatically a change log. And last thing, to be highly reliable, you will want to continuously check this contract is really correct, considering live traffic observations. So altogether, question for you. What is the source of truth for your Open API documents? Put some thoughts on it. That's really important. And what about revisions? And how are they organized? Can you deduce timelines? And so you can infer the API, your API lifecycle from these revisions of Open API documents. And lastly, how are you automating these Open API documents through your CI/CD pipeline? These are really the questions that matter for an organization. So thank you so much for staying with us today. We welcome you at the booth and also online. Cisco DevNet is Cisco's developer program. You can see us at developer.cisco.com, and the Panoptica solution is available at panoptica.app. So have a great day, have a great conference, and see you soon online.